Hey everyone, it's Mr. Slomka, and today I wanted to talk to you about section 11.2, which is on populations versus samples and parameters versus statistics. So this is a very vocab-heavy section, but that's good news because that means there's not very much calculation. We're going to look at these four terms and some of the other peripheral ones, and we're just going to make sure that we understand them clearly, so when they show up in some examples, we'll be able to identify them quickly and easily. Let's take a look at our first relationship. So the first two terms we're going to look at is the terms population and sample, and these are very closely related. So a population is going to be a collection of all data. So that means we're not going to have any skips, we're not going to jump over anything, we're just going to use every single piece of data that we can get our hands on. Every member of a group is surveyed. Sample, on the other hand, is going to be a part of a population. Not every member of a group is surveyed. So let's say that you had a survey question that you wanted to ask two women. Now, there are so many women in the world that there's no way that we could get that answer from every single member of the woman population. But we could sample women, and then when we do that, then we could use that information to kind of generalize to most other women. So this is our first collection right here. Our second set that we're going to be looking at is this right here, which is parameter and statistic. So a parameter is going to be a numerical description of a population. Once again, remember, every member for population. A statistic is a numerical description for a sample. And once again, sample is going to be a part of a population. So once again, these are related in the same kinds of ways. One of the things that's helpful is that population starts with a P and parameter starts with a P. Sample starts with an S, and statistic starts with an S. So you can use that to kind of make sure you don't get them twisted. There is one last term here as well, and that is hypothesis. This is a scientific term, but we're going to use it here as well. In this case, a hypothesis is going to be a claim about a characteristic of a population. So as I was stating earlier, maybe you're going to sample some women, and when you do that, you're going to come up with a hypothesis, and you're going to try to use that information to generalize to the entire population of women, which means that you would be building a claim, you would be building a hypothesis. Okay, let's start off with our first set of example problems. So now this first set of example problems is a really good one, and basically what we're going to be doing is we're going to be looking at the similarities and differences between these words sample and population. So I'm going to read a couple of example problems for you right here, and we're going to try to identify the sample and the population for each of them. So this first one says, in the United States, a survey of 2,184 adults aged 18 and over found that 1,328 of them own at least one pet. So I'm going to give you a hint here. When you're looking at these types of examples, there's going to be extra information that we really don't care about because we're really only interested in the population and the sample. So most of this information that we're interested in is going to come at the beginning of the problem, and then this more interesting fact that happens at the back is really not very important to us. So let's talk about the population. Remember that a population needs to be a broad group. And so our population right here is going to be adults. Specifically, adults that are 18 and over that are living in the United States. So this is very, very general, and it's such a big group that it would be hard to talk to all of them. So in this study, what they did is they only sampled or surveyed 2,184. Now, this is the same type of information that we had in our population. They're still adults, they're still 18 and over, and they still need to be from the USA, but this time instead of doing all of them, we're only doing 2,184 of them. So there's your sample right there. Let's take a look at another one. So this one's about some mileage for some new cars. It says to estimate the gas mileage for a new car sold in the United States, a consumer advocacy group tests 845 new cars and finds that they have an average of 25.1 miles per gallon. Once again, this is the interesting thing that you would want to kind of take as your takeaway, but that's not what we're interested in. So we're going to be looking at the population, and the population here really isn't a person this time, but rather it is going to be a piece of data, and that piece of data is going to be gas mileage of the new cars that are sold. So this is going to be a specific facet of the car, not even the car itself. Now the sample is going to be those 845 new cars and their gas mileage, and that's going to be the sample that we were able to obtain in our study. Next one. At Stoney Creek High School, Mrs. Kreiderman surveys the senior class and records their gown size for each graduate. The average gown size is one size fits all. So now this is a population that you could actually reach out to, and Mrs. Kreiderman is certainly in charge of reaching out to that entire population. She cannot skip anybody. So our population is going to be all seniors at SCHS. And when Mrs. Kreiderman is creating her survey or asking her question, she needs to sample all the seniors at Stoney Creek High School. And since our population and our sample are the same, that means that we are talking about a census right here. Our survey will discuss our question with every single member of the population. It is a lot easier because this is a small population compared to some of these other ideas we had above, and that means that you can do it and that you should. Next, the owner of a dance studio asks 32 dancers what their favorite type of dance is, and 25 of them say hip-hop. So hip-hop dancing is great, and that's awesome, but we really don't care. What we're more interested in is the initial part. So a dance studio is relatively small, so you should be able to talk to every single member of the population, and the populations are going to be the dancers at the studio. But only 32 dancers are going to be answering these questions, and so those are going to be our sample. I want you to notice once again, a lot of this information is the exact same for both, but the sample is a little bit more narrow. Okay, let's talk about our other set of vocab terms. We're getting close to our end right here. So our other set of vocab terms was perimeter and statistic. Now both parameters and statistics are numerical values, so we're going to be seeing a lot of numbers. The parameter is going to be information about a population. A statistic is numerical information about a sample. So for this first one right here, it says, for all students taking the SAT last year, the mean mathematical score was 514. So now there's a couple of key things here. First of all, it does mention all students, so that tells us that we don't have any skips, so it should be a population. Next, to gather that information about the SAT, that's doable. All that information is going to be condensed and held in one particular place with College Board because they run the SAT, and so they should be able to gather that information about the entire population. That makes this a parameter. It's based on all SAT takers, and there is one convenient source to get that information from. You don't have to go door to door. Next, a survey of 1,060 women aged 20 to 29 in the United States found that the standard deviation of their heights is about 2.6 inches. So now this case is a little bit different. Just like we were talking about at the beginning of the lesson, surveying all women would be extremely challenging. So they didn't. They only were able to find a sample, and that makes this information about standard deviation a statistic. It's only based off of a sample of women in a study. Last one. Now that all tax returns have been completed and the IRS has determined the average hourly wage for teenagers employed in Rochester is $8.13. So the IRS is once again one of those large type organizations that can collect a lot of data and actually look at all of it at the same time, which means that discussing a population is not unheard of. So we can get our hands on some parameters right here, which is numerical information about the entire population. So this is based off tax returns. You have to fill out your tax returns. You cannot skip it. It would be illegal. And so all that information is collected, and it's thorough, and so we can use that in order to make sure that we have accurate information. All right, our last piece. The last piece that I want to discuss with you is a hypothesis. Now, in general, I'm quite confident that you know what a hypothesis is, but I just want to make sure that you can see what they look like in a statistical situation. So right here, what you have is you're going to have a situation, and it says you are flipping a coin 50 times in a row. And it says, I want you to make a hypothesis about the percentage of times you will see a head appear. So now here's the thing. If I'm flipping a coin, I know that half the time it's probably going to be heads, and half the time it's going to be tails. So what I'm going to guess is that my percentage is going to be 50%. Otherwise, 25 times for heads and 25 times for tails for 50 flips in total. That would be my best guess. And I think I feel confident about it. If you want to take that a little bit further, let's keep going. So it says, what could you determine about your hypothesis if your coin landed on heads 26 times? Now, 26 times is not exactly what I said. If you actually do the work, 26 divided by 50 gives you 52%. That doesn't match exactly what I had, but it is really close. And because of that, my hypothesis, 50%, was not the same as what occurred in the experiment, but I was very, very close. So I feel good about my hypothesis. I don't want to change it. I think that what I said was accurate, and that maybe this was a little bit of a fluke. Now, what can you determine about your hypothesis if you had heads land 32 times? So once again, if you do the work, 32 flips were heads out of 50 flips in total. You get 64% of the time it was heads. Now, this is definitely more different than what I had for my original hypothesis, which means that my hypothesis is not as great anymore. So it says my hypothesis 50% is now just straight up incorrect. My claim does not match the results of the experiment. Maybe we have a particularly strange coin on our hands, or maybe it's fixed or rigged so that it doesn't show up tails as often, and it does show up heads more often. And so you would use that in order to kind of test the situation a little bit. So you're going to want to build your hypothesis, and either you can confirm it, or you're going to need to go back and alter it and change it because it's not that good. Okay, thank you so much. If you have any questions over these topics, please email me. And then now, please move on to the worksheet and the final check.